2 or 3 people in the business who've literally written the book on the floods. Jim O'Connor from the USGS in Portland is one of those 3 people. Any paper you read about the floods, Jim's made major contributions to that. So he's been continuing to be up here working. We were out up at Hayden yesterday looking for old gravels and for tracking down perhaps some prehistoric rivers or things that happened after the salts came through. And Jim and I did some of the dating over dams and so forth. So Jim's still actively working on floods research here. So it's really a great honor to have him over here and to do a talk about some of the things we've learned since 100 years ago of J. Harlan Bretz and Joseph Hardy and a few others. Kind of wonder what happened here. So Jim, take it away.
Thanks, Brad. It's great to be here, and I'm really jazzed about this funding for the Cosmogenic study of these radioactive erratics. Both Ben and I have been involved with that a little bit, but it's really going to be it's going to be a lot of great new data that bears on. It'll help us understand the timing of floods. So yeah, I do work for the USGS. Of course, the USGS is part of the shutdown. So since this is being recorded, I just have to clarify that I am here as part of my Inland Empire tour while being furloughed from the government.
You're not really here?
Not getting paid for it.
And this is now the government computer. Okay. I've given quite a few talks on the Missoula floods, but this one's going to be a little bit different. So this is kind of an experiment. We'll see how it goes. I'm going to talk a little bit about the Spokane area since this is where we're at. I'll zoom out for a little bit, but then I want to come back and hopefully this will be somewhat interactive and talk about what we as a scientific community have learned over the 100 years since Bretz published his first papers. And then I want to talk a little bit about what I think my preference would be to discuss with you all what are some of the outstanding questions that will keep research going for at least another 100 years. That's the plan. So this is a page from J. Harlan Bretz's notes, August 1st, 1922, and this is his first Missoula flood station. I would say it wasn't the Missoula floods yet at this point, but he had spent several years working in the Plum River Gorge, mainly in other issues. But in 1922, invited by the high school teacher Thomas Large in Spokane, he came to Spokane, and his first stop was at Pantops Station, just south of the city of Spokane, and there he records what he sees there. Basically, this coarse-grained gravel with big boulders in it, a fluvial gravel, water deposit, and I don't know if I can make a pointer. I can just point my hand. With huge boulders in them, 2 to 3 feet in diameter, deposited by water, escaping water flowing south, and his immediate interpretation was that it was that story has changed a little bit. This is basically the beginning of his Spokane, what he first called Spokane flood, and what we now know as the Missoula flood. So here's Spokane, here's Liberty Lake. We're probably right, this must be Saltese Flats right here. We're in here somewhere. But Pantop Station is right here, and here are, courtesy of Google Earth like Glenn, as he is now known around the world. Those are his stations in the Spokane area, his 1922 stations. He went quite a few other places that summer, mostly in the Channel-Scabland. And then he wrote for, and two papers came out in late 1923. Glacial Drainage on the Columbia Plateau, published by in Geological Society of America, bull that came out in September of 1923. And then another paper in the Journal of Geology that was in the November-December issue. And in these papers, he lays out the case for huge flows. In fact, he called them floods, the Spokane floods. But he was a little bit timid at that point about how big they were, and also where the water might have come from. But for the next several summers, every single summer through 1929, he came back out there, pretty much always with a pipe in his mouth and a hat, and the students who tend to dress just like their professor. Does it still work that way? I don't know. Here they are in Grand Coulee. I'm not sure exactly what year that is, but every year, as I said, between 1922 and 1929, he was back out there with these student groups. And these are the field locations, and they're most dense, of course, in the Channel-Scabland, but he made forays up the Snake River, and he made forays into British Columbia. Those British Columbia trips were in part to look for a flood source. And then he also came back, and this is kind of a separate story that I won't get to, but he came back in 1952 in the final field season, basically to put the final dagger into the vampire opposition. And out of this work came more than a dozen papers laying out the case for the floods. But this is a story that is very, very familiar to you all. But it was a very intense episode of flood research, and part of it was motivated by this beatdown that he suffered at the Cosmos Club in Washington, D.C. in January of 1927, when the forces of the USGS sort of pushed back on this idea of a flood. So the paper that summarizes his presentation to the Cosmos Club is this one in the Journal of the Washington Academy of Sciences. And then you can see this 3 papers, or 2 papers in 1928, 2 in 1929, another in 1930, just ferociously making the case for the floods. And his work, as you all know, was amazing. This is a map that he made in 1925 with a satellite image. Next to it, you can see how impressive his mapping was, especially given that there are few roads. There wasn't much in the way of existing topographic maps, or at least they were incomplete. It's an incredible map. He traces the floods from the Spokane area, all the way down to the war zone of Portland. At least I'm told it's a war zone. But this is where I live, right down here. The most beautiful version of this map is this colorized one that was published by the American Geographic Society in 1928. And I think, Glenn, this is something that you put together as a laminated version. You should come up and take a look at it. It's a masterpiece. One little interesting tangent that relates to the Missoula flood story and well, relates to science in general is here's a map of a blow up of part of that map showing some of the Scadland tracks. Here's the Cheney-Spokane track, the Crab Creek Telford track, Grand Coulee, and then Moses Coulee off to the left. And there's a little place here called Ewan at the south end of Rockaway and the south of Cheney, at the edge of the Cheney-Spokane tract. And another character in this story, Joseph Pardee, was in Ewan in 1920, October of 1920, 125 years ago, plus 6 days. Pardee is famous for his work on Glacial Lake Missoula. He published a paper in 1910 on Glacial Lake Missoula, really defining its extent and the fact that it was dammed by a lobe of the Cordilleran ice sheet. But he worked for the USGS. His main job was as an economic geologist, but he worked mainly in the Pacific Northwest. But on October 5th, 1920, he stops at Ewan and he looks off to the west, and he describes the channel Scadland. He describes it being formed by glacial floods. He describes the process of how these coulees form by retreating cataracts. And this is 2 years before Brett's appeared on the scene. And that's all we know. What we do know is that a few years later, Pardee published a paper where he describes this terrain as not being flood carved, but as being glacially carved. And there are all sorts of rumors about government control over his reports, but we really don't know what happened there. We don't really know the extent of interaction between Pardee and Brett's. big ice sheets formed during the last ice sheet. Laurentide ice sheet covered most of North America, but then in the Rocky Mountains and the coast range of British Columbia, we had the Cordilleran ice sheet form. It sent lobes of ice south. Big one buried Puget Sound, the kilometer of Seattle, a little bit under a kilometer of ice. That might have suppressed some of the noise coming from the baseball field last night, but that's a pretty amazing story too. That might be why some people didn't show up today. They're still sleeping in. Here's so part of the flood story in the Northwest is this ice sheet coming down and blocking drainages. But another part of the flood story is that during the last ice age, a lot of the closed basins of the Great Basin area, areas of internal drainage, they filled up with water because it was colder, wetter, less evaporation. And so big lake systems like Pluvial Lake Lahontan and Lake Bonneville, which was the Ice Age predecessor to the Great Salt Lake, they also created floods too during the last ice age, including a couple relatively small lakes in Oregon, but they too produce floods. And here is some of that. As a close-up, the main lobes of interest are the Purcell Trench lobe, which came down and blocked the Clark Fork River, thus forming glacial Lake Missoula. But also important to the Missoula flood story is the Okanagan lobe, which blocked the Columbia River, forming glacial Lake Columbia. And then also, probably important, but we don't really fully understand the story yet, is the ice slope coming down the Columbia River itself blocked, came down to the confluence of the Columbia and Spokane River, and that formed glacial Lake Spokane. People argue about this, but I think a lot of the lacustrine beds that you see in Latah or Hangman Creek, what is the preferred word for that drainage?
Either one.
Either one. Okay, so I got to keep saying Latah or Hangman Creek, whatever.
That's it.
Yeah, so there's lacustrine beds and they're separated by flood beds, and those lacustrine beds, I think, are from glacial Lake Spokane, but other people have different opinions. So Purcell Trench lobe, Columbia lobe, Okanagan lobe, all are a factor. Purcell Trench lobe fails, sends the floods across the Channel Scabland, sort of delineated, basically copying this map here, delineated by the dark gray, converged at the little gap through the Columbia River Gorge, back flooded the Willamette Valley as far south as Eugene, and then sent water out into the Pacific. And there are sediments that extend out onto the abyssal plain 1,000 kilometers from the coast. Great Salt Lake, its Pleistocene predecessor, Lake Bonneville, also filled and overtopped the divide into the Snake River drainage here and sent a big flood down into the Snake River through Hell's Canyon and then down to Columbia as well. We don't see evidence of the Bonneville flood much past Lewiston because it's been covered or eroded away by the later Missoula floods. And as an aside, the first Pacific Northwest megaflood description was really associated with the Bonneville flood. When G.K. Gilbert, who was studying the early USGS was studying this Lake Bonneville, and he came up to this divide here at Red Rock Pass and described the outpouring from that, in his words, a veritable debacle. He didn't use the word flood, but he termed it debacle, and that was in 1877, I think, 77 or 79, somewhere around there. And in his field notes there from that year. So that was probably the first written account of a mega flood in the Pacific Northwest. But then that flood, that's a whole different story, but that flood was kind of lost for several decades until Helen Aldi came back in the 1960s and really reported the effects of that flood on the Snake River Plain. Bratz went down and looked at some of these flood features and described the scabland there, but did not really make the link to the overflow of Lake Bonneville. Okay, let's see. So just a little bit, well, I'm going to go on. So, as a consequence of the Purcell Trench lobe failing to keep Glacial Lake Missoula in check, you had these floods come across. Pretty much all the water came down the Spokane Rathdrum Valley, and then once it came out of the valley, it took a variety of routes, this whole plexus of routes that are of the Channel-Scabland. But depending on where the other glaciers were, these routes vary. Some floods came down, followed the Columbia all the way around, came down the Columbia Valley near Wenatchee, but that had to occur before the Okanagan lobe had advanced to block the Columbia. We know at least one flood did do that. There were floods that came down Moses Coulee, at least 4. That had to happen before the Okanagan lobe blocked the entrance to Moses Coulee, but it was probably facilitated by the Okanagan lobe first blocking the Columbia and raising Glacial Lake Columbia to allow water to come over. Some flood water, for most floods, came down through Grand Coulee, but part of that story is, when did Grand Coulee form? And that's kind of an open question. Was it there prior to the last glacial flooding episode, or did it form during that flood episode? And how much of it formed? And then at certain times when Glacial Lake Columbia behind the Okanagan lobe was high, floods coming out of the Rathdrum Valley would cross into the Crab Creek Telford Scabland Tract, and then it turns out from hydraulic modeling we've been doing more recently that almost every flood would have come into the Cheney-Spokane Tract and down into the Pasco Basin. Eventually, all these flood routes lead to Pasco Basin through Ula Gap this one distinctly. I'll come back to number 8, but here's basically how it worked. You lay out high water marks, you run different discharges through the software until you get one that creates a water surface profile. So this is a longitudinal profile, starting from Spokane, going up to basically the outlet there. And those two, the arrows pointing up, indicate points that I interpreted were flooded. The arrows pointing down are points that I interpreted were not flooded. And the absence of evidence is generally not a very solid approach. There's not too many places where I was really sure it wasn't flooded, but there's a lot of places where there's pretty good evidence that it was flooded. And most of that evidence was ice-rafted erratics, and that's why dating these high ice-rafted erratics will be really interesting, because it will tell us when the biggest flood or the biggest floods might have been. So two different discharges are shown. The lower line is for 15 million cubic meters per second, and the other one is for 17, and I concluded back then that discharge of about 15 to 17 million was about right to match the high water marks. So this Liberty Lake one is pretty interesting. It's a divide crossing. It's not an ice-rafted erratic. It's a place where the water got high enough up the Cable Creek drainage that it came through this saddle here. And part of it is morphology of the saddle. These cross divides typically have these nice trapezoidal cross sections. But this one, this would have been pretty shaky evidence just on the morphology. But this gravel pit right down here, which I went and visited in 1987, had these beautiful sort of coarse-grained deltaic deposits exposed in there. So the floodwater is coming up here. It's also coming up here. Water spilling over, spilled into this backflooding water, creating this little delta that was nicely exposed in 1987. I haven't been back there since, but it's just up the road here.
So, Jim, what's your judgment of how deep the water was in here when you were going through this?
Yeah, so 780 meters, which is like, I think, 2560.
Okay.
So this is the 2560 contour right there. So it might have gotten up to 2600, but I know that across the divide it had to be at least 2560. So that's one of the more solid high water marks in the area. There are also quite a few ice-rafted erratics that have been found or have been reported, like in the Lake Coeur d'Alene Basin, and they provide pretty good information on how high the water got. So did this in 2 places back then, one in the Spokane area, and then also in the Lula Gap area, where the discharge was 6 to 10 million cubic meters per second. So 15 up here, 6 to 10 down here. We learned by working in the Lula Gap area that Lula Gap really was not the control as long been thought. It was constrictions in the lower Cumby River Gorge, backed water up to essentially impede flow coming through Lula Gap. as I described, there's been different pathways for floods depending on what the ice slopes were doing. So I'm going to show you a scenario where the Okanagan lobe is blocking the Columbia, so floods cannot come down the Columbia River. And it's also blocking the head of Moses Coulee, so all the water has to come out through either Cheney-Spokane, Crab Creek, Telford, or Grand Coulee. And this scenario is also based on the current geometry of Grand Coulee. So a point where Grand Coulee has been cut down to its current level. And from the stratigraphy in glacial Lake Columbia deposits worked out by Brian Atwater, we know that most of the floods experience a topography similar to that. So this is kind of what the model grid looks like. Portland, Spokane, Missoula. This is what the grid looks like before you let the water go. And so time 0. You have the ice cam there, sort of marked in the black. We have this deep glacial Lake Missoula behind it. The darker the blue, the deeper it is. And what we're doing here is kind of modeling an end-member scenario. It's a maximum size glacial Lake Missoula. We know it didn't reach this size every single time. And we let that water go. We take the dam away instantaneously, which is probably not practical, but this is kind of end-member scenario. And we'll see if this works. Okay. There it goes. So Portland's down here. Okay, so we let the model go for 120 hours because in reality, each hour of modeling takes about 10 hours on the computer. So, by 120 hours, the flood peak has arrived in Portland and has started its downward trend. So I can just watch this forever. And we'll run it a couple more times here. So you can see how much water is. All right, there we go. So you'll see that the first water breaks out across the Cheney-Spokane, then a lot of water through Grand Coulee. Just a little bit comes over to Crab Creek Telford track. But it at first does pond up behind Lula Gap, but then as flow is working its way through the gorge, you can see how deep it is in the Umatilla Basin, and that is actually increasing the stage in the Pasco Basin. And it takes a lot longer for the water to eventually work its way through the gorge downstream. So we're going to move on, even though I want to keep watching it. So here's at time 120 hours is what the scene looks like. The lake is empty. There's still deep water in Lake Pend Oreille because there's always deep water in Lake Pend Oreille. Spokane is history, but the water is mostly passed through there. We're kind of at the maximum inundation of the Willamette Valley. Eugene is down here. And in Portland, this is kind of the situation. It took 36 hours for the water to get there. So if you're on Instagram, you would know that the flood was coming. If you read the newspaper, you might not. And then it rose, over the course of another 60 hours to the peak stage. And what was gratifying about this is these models don't really care what the high water marks are that you know about. You're just letting the water go and see how it interacts with the topography. And in this situation, the maximum stage predicted by the model is pretty close to what the highest field evidence is in the Portland area. So that was either lucky or whatever, but it was gratifying. In other places, it didn't work out so well, and that has been really provided some sort of rich questions to continue to work on the modeling. Okay, what about here in Spokane? I'm not sure. Things would happen a lot faster here. So here's what the situation looks like after 1 hour. The ice dam is ruptured. The front of the water is right about here after an hour. And then it reaches the peak in another 45 minutes. So it would not be good news for the Spokane-Cheney chapter of the IceAgeFloods Institute, especially if they're having a meeting right here at the moment. And this was also gratifying too, because it predicted peak discharge for this, in this scenario, is about 15 million, which is what the modeling, what the old modeling guided by the high water marks predicted for this region. So I think that was mostly luck, but I'm running with it. I'm happy with it. So water would have been 700, 800 feet above us here at the peak. So how does that compare to gauge discharges on these rivers? I happen to notice that there's a cableway crossing the Spokane River just down, right over there. And so for the Spokane River, the highest known peak discharge is about 1,400 cubic meters per second, and it's 1894 flood. And so that's about 1/10,000th of what the Missoula flood peak discharge was. You would have had a hard time measuring it with that cableway. On the Columbia River, much bigger river, big stages, a terrifying cableway across that river. They don't use that anymore. It's gone. But that was the old way that was the way that they measured discharge in the Columbia. The biggest historic flood in the Columbia, also 1894, was about 3,400 cubic meters per second. About 1/200th of the largest Missoula flood. Okay. So now, I'm going to just list some of these things I think we've learned over the last 103, or maybe 105, if you count Pardee's observation, about mega floods in the Pacific Northwest in general. And I'll come back to this in a second, but I also have this list of what I think are some of the opportunities for the next 100 years of research. And pace ourselves knowing what's coming up. So the first thing is that the science of the floods, and I would say the science, at least the science and stuff that I've been worked on, it's not like the science you learn in high school or middle school. It's complicated. It's not just, making observations, testing hypotheses. It involves people, it involves personalities, it involves false starts, some false starts that were correct but never consummated, like Pardee 1920 observations. It involves false starts that were perhaps on the wrong track and have hindered understanding. And I think, in my opinion, it's this idea of the Spokane glaciation might be one of those wrong tracks, but we still learn from all these. But anyway, it's complicated. I think in part Brett's struggled because he was kind of ornery and naturally, perhaps naturally attracted opposition. I don't know. I feel that happens to me. Pardee was quiet. He apparently did not have a strong personality, and that might be part of the reason why his first observations never really went anywhere. That's a little philosophical, but more pragmatically or more down-to-earth stuff that we've learned is that there's been perhaps 100 floods across the Chen-Spokane. Most or all probably from Glacial Lake Missoula. The chronology that we've worked up so far shows that those floods occurred between about 18,000 and 15,000 years ago, and that's a combination of radiocarbon dating and this cosmogenic nuclide dating that Isaac Larson and Jesse, I forget her last name, are working on. The first floods, I talked about those 5 pathways of the floods coming across. It seems like those pathways, well, the Cheney-Spokane operated in every single flood scenario, at least judging from the modeling that we've done. But the first floods sent water down the Columbia River before it was blocked by the Okanagan Road. And those may have been some of the biggest floods. And we have dates from those, cosmogenic dates of about 18,000 for those. That age range of 18 to 15,000 years ago indicates that these floods were certainly witnessed by indigenous people in the area. There's archaeological sites in the Columbia River Basin that go back to about 15 or 16,000 years ago. The new sites that have been dated in the White Sands area, the footprints, the amazing footprint sites, those go back to 21 or 22,000 years ago. And there are also these indigenous oral histories of these floods. And there are certain places that are sacred to the tribes now because they were places where they could escape the high water. Let's see. There were also floods from other sources like the Bonneville flood, also Glacial Lake Kootenai, and then Glacial Lake Columbia itself probably failed catastrophically at the end of the last ice age. And those famous current ripple field at West Bar, are happening on other planets, particularly Mars, which also has kind of a channel scanline, but with meteorite impacts dotting the features. I'm sure I've missed a few things here, but these are the things I think about in terms of what we've learned. But also, there's more than enough questions to keep all of us busy for another 100 years. And these are just the questions we know about. I guess there's this famous quote by Donald Rumsfeld, there's the known unknowns, but then there's the unknown unknowns. I hate attributing it to him, but it's an important point that oftentimes the most interesting questions are totally unexpected. And so putting together this type of list is always a little, I feel a little squirmish about it. But these are some things that I think will consume energy. I'm really interested in what was going on in the late 19-teens and early 1920s involving Pardee and Bretz and Pardee's chain of command at the USGS. And, you know, how much did Pardee know? When did he know it? How much did he communicate with Bretz? You know, with the work that Glenn has done in making these notes available, you know, there's a chance to make some headway on those questions. How big were the floods? We're still, you know, the hydraulic modeling is in the works, and that's something I'm pretty interested in. And we have some idea, but you know, I cherry pick places where the modeling seems to work in terms of the field evidence, but there's some places where it fails miserably. We don't really understand why yet. Part of it might be because some of these areas were actively eroding as the floods were coming through. That certainly they were eroding, but may have been eroding in a manner in such a way that they affected the overall flood dynamics. Other flood sources. There was a paper that came out a couple years ago by Jerome Lessman and Joel Gombiner arguing that the floods in Moses Coulee may have been from water coming down the Okanagan, from under the Okanagan below of the ice sheet. And that could be. I don't think it's necessary. I think we can explain it with Missoula flood sources, but I think we have to keep our mind open to other potential sources for floods, for the flood features that we see out there. The Spokane glaciation, that so many of the early geologists talked about. You know, what is the story there? Was there multiple advances, or are some of those deposits maybe interpreted as some other process or replacement?
We considered those penultimate 125,000 years ago.
Yeah.
So there wouldn't be Missoula.
Right. But you know, why was Bretz so hung up on the Spokane glaciation being the source, being the time of the floods? And you know, there's some ideas about that, but it's the sequence of flood pathways. We're pretty sure that the Columbia River route was first, but you know, what was going on with Moses Coulee, Grand Coulee, when you know, was it did it form prior to the last glacial episode, or did it form during the last glacial episode? And I think the jury estimates for earlier floods, where do they, as I mentioned, we don't really know where they came from. We don't really have a great sense of their timing either. Some of them are paleomagnetically reversed, which makes them nearly 1 billion years old, but a lot of deposits we don't really know how old they are. And then some of the some broader topics that I know some people are working on is, what might have been the effects of these floods in oceanic circulation and perhaps climate at the end of the last ice age. Big pulses of fresh water coming into the eastern Pacific, they could affect the oceanic circulation. And what were the ecologic and cultural consequences of these floods? I get every year I get an email or a phone call with someone asking. Usually it's a biologist asking, well, could the floods have been the mechanism to get this one clone of aspen that we see in Missoula that matches the clone of aspen that we see in the Willamette Valley? I kind of made that up, but it's that type of question. It's fish distribution, vegetation distribution, and then of course it must have had cultural consequences that as well. So I'm happy to hear feedback on any of these opportunities or
So, Jim,
yeah.
I hadn't heard of Glacier Lake Kootenai. Where is that?
It's, let's see, it's in British Columbia. I had it on a map. But as the Cordilleran ice sheet retreated, and I think it would have been the Columbia lobe. There was a strange geometry that developed that created a ice dam lake in southern British Columbia. So this is during the retreat, so well into the retreat phase of the ice sheet. And at some point that lake failed, and there's a paper that came out a couple years ago on this, and sent a large flood down the Columbia. And it's possible we see evidence of that flood in the Wenatchee area along the Columbia. It would have been after the breakout flood from Glacial Lake Columbia, and it was after this glacial Kootenai flood was after the glacier peak volcanic eruption of 13,500 years ago, because these low deposits have that tephra on them, the flood deposits, presumably from that flood.
Did you say that the West Bar might have been related to that?
I think the West Bar is probably from the failure of Glacial Lake Columbia. So at the end, what we know from the stratigraphy that Brian Atwater worked on is that Glacial Lake Columbia persisted several hundred years past the last Missoula flood that came into it. So it's holding this lake up, it's draining through Grand Coulee. So the Columbia River at the end of the last ice age was coming through Grand Coulee. But as that Okanagan lobe thinned, that lake eventually, it would thin to a position where that lake would be high enough against it that it would the Bonneville flood, which was a much longer duration flood. There's no current things on any of the flood bars. The flood bars are just as big as Missoula flood bars, but that flood was much longer duration than any of the Missoula floods. And so these long duration floods, I don't think produce bars with preserved current ripples. I'm getting way out of the bounds of your question, but sometimes I just talk about what I think I know about.
Just an observation, I don't know if you spent any time up in the Barnes Ferry area?
No, not much.
Well, there was a glacial lake Kootenai up there also, and you can see the Crestman shorelines, whatever you want to call them. And it's really interesting. I mapped a lot of that country years ago, and one of the things that makes it different is the custom material is calcareous. So the sediment that was deposited there came from, I assume, some limestone, some sort of the belt formations that were more calcareous. But it was really interesting because I had mapped some of the lacustrine sediments further south, and they were never calcareous. So their material is different.
Yeah, interesting.
So anyway, there was another glacial lake Kootenai up there.
No, maybe the same one. I don't really know the geometry of that glacial lake Kootenai situation.
Lake Ponderay, do you know much about it? Because from what I've been able to learn, it's like older than the floods, 100,000 years, but as you point out, it's one of the deeper lakes in North America, actually. And it's also about half full of sediment now, currently. And I wonder why, unless it was like right where the dam was and it was kind of being, dug out as it went under the dam or whatever, why didn't it fill up like the Rathdrum Prairie did? Because there's just a big basin of rock that's full of gravel, fairly level except for the ripples and whatnot. Do you have any hypothesis about that?
Yeah, that's a good question. The only thing I can think of was that was basically where the ice dam was.
Yeah, the current was too strong.
And so each Rathdrum Prairie is filled by flood deposits, but also from the outwash from that into the Ponderay lode. I would think that area, right where the dam was getting pretty cleaned out each flood, whatever the failure mechanism.
And then at the end of the flood period, it would fill with some sediment, obviously.
Yeah, why didn't it fill with sediment?
Right.
There's an answer.
What's that?
Richard Waite came up with the answer in the 80s.
The
Tunnel Valley.
what's that?
Tunnel Valley. The flood went into contact with the bedrock and the ice because of the friction, making it the warmest and the weakest. And that way you contain the flood under the lobe. So you're flushing it like a toilet. And you're flushing it down to 700 feet below sea level, which is the contact with the bedrock and the ice. So when it comes back up, it's coming back up under glacial Lake Columbia. All right, so that's your septic tank. So you get your toilet to your septic tank, and I didn't come up with this Atwater did. All right, so when I use early publication, no Atwater, Brian Atwater. Yeah, he's the one that came up with glacial Lake Columbia and the stages of glacial Lake Columbia. So he's a real important contribution. And in his modeling, that's what was going on. And then Waite ran with it there and said essentially it's subglacial or inglacial, much like what the glaciers are doing in Greenland and in Antarctica today, but mostly in Greenland, where you can you get surface water melted, then they go down these trenches, these holes, and go down to the bottom and then come out. So whatever melting you've got at the top isn't the outburst flood. The outburst flood is carving out at the bottom of the ice and then coming under Glacier Lake Columbia, which raises a whole bunch of interesting possibilities that have not been considered. And one of them is, from a flow dynamic situation, by definition, that's a high concentrated density flow coming out under Glacier Lake Columbia. Glacier Lake Columbia is the ambient water, which is not dense at all, it's clear water. So when this stream of flooding comes out, you get a shear zone between the ambient and the supercritical. So Glacier Lake Columbia is sitting there as low flow, subcritical. The flood below it is supercritical. The shear zone and the hydraulic jump is in that transition. Oh, I know you're probably not following this, but Jim gets it.
Anyway, you got dense water flowing under clear water, and the clear water is going to rise up and slop over the top.
Yeah.
I think part of his question though is, after the floods, you still have the.
But I'm getting to that before she's sidetracked. If you're talking too long, yeah.
I should have known.
Okay.
I have a question.
Be
How cold
patient.
is it in this room?
Yeah.
It's freezing.
Next ice age is on.
So anyway, so as the hydraulic water and hydraulic pressure drops in Glacier Lake, Missoula, the force behind that gravity flow decreases to a point where the sediments you're carrying down and under, that's your U-bend in the toilet, down and under fills, because you no longer have the force to push that sediment through, and it's like when you crap in the toilet, you plug it up, that's what's happening. And so it backfills up with the sediment to the ice, under ice surface. And that's your plug until you raise Glacier Lake Missoula high enough to unplug it. And like I say, that's Atwater's ideas. That's not mine, but I think they're really good ideas. Okay.
Didn't Joe Gallmeister publish something on turbidity currents and out in the Pacific from the floods?
Yeah.
I
So
think that's what Mike's talking about.
So that's one area of active research is trying to understand the stratigraphic record of these Missoula floods offshore. Maureen Walzak, who's now at University of Washington, has been coring off the mouth of the Columbia. Joel Gombeiner's work with Henry has looked at a core that seems to record, rhythmite-like deposits out there, and some of this work is motivated by the ocean circulation question. How do these freshwater pulses perhaps affect circulation patterns?
Okay, question. We hear both Glacier Lake Missoula flood and Spokane flood. The two terms are even in the same paper, and you wrote one of them, which you actually preferred Spokane flood. So give us an idea of the understanding there. Are they separate, or are they the same, or what?
Brett's termed these floods to Spokane floods because, as far as he could tell, they came from the Spokane area. And it really wasn't until Carty's paper in 1941, or was it 41 or 42, where he talks about
After he retired.
the unusual currents that the consensus became,
see both terms in the same paper, used synonymously. I'm not talking about different sources.
Yeah.
As you point out, is absolutely correct. It had different sources.
Yeah, I think the common vernacular now is Missoula floods, and you know, part of the issue, as we've discussed, is that you know, once you get away from the basalt in this terrain here, this terrain here is so easy to interpret as a glaciated terrain. The flood bars that block the lakes like Hayden Lake and Coeur d'Alene and Liberty Lake and Saltese Flat, those could be interpreted as glacial cane terraces very easily. The scoured granite looks like it could be ice sculpture. So I think all the early geologists, the earliest geologists, interpreted this Spokane Valley, Rathdrum Valley, as a glacial trough. And that was the paradigm that Brett's entered into when he came here. And that first slide, he interpreted Pantop spar as being basically an ice contact outwash feature. And he never saw anything else up here that really changed his mind. And, you know, earlier geologists had never seen mega flood deposits or recognized them for what they were. And so this chaotically bedded coarse grain stuff, it was never called till by the early geologists. It was called glacial drift. And so I think the paradigm was that this is glaciated. And you know, for a long time. And I think that was one of these sort of wrong turns that affected, you know, interpretations of the flood. And that issue is something that really came up in 1927. What was the source of all the water? And you know, Gretz was thinking some sort of subglacial release from this.
The Jocko.
Yeah, and he was looking for volcanism up in British Columbia as an explanation. But
So were the Canadians later on too.
you know, Pardee, sounds like Pardee had a pretty good idea where the water came from
Yeah.
early on.
Did Pardee get his idea from Chamberlain?
Pardon me?
Did Pardee get his idea from T.C. Chamberlain, who basically said there was an outburst flow in Lake Wanderer that came down Rathdrum Prairie in 1885?
Yeah,
So I just ignored it.
I don't know about that story, so Pardee, I mean,
It was about 3 sentences in a 100-page report, so.
okay, that's interesting. I'll have to look at that. And the lake was known about. Chamberlain and every quaternary geologist that came through Missoula saw the lakeshore lights up on the slope, even before the M was on Mount Jumbo or whatever. And so the lake was known about for a long time. The geologists often will get their ideas from earlier geologists who make an offhand comment in the paper. I know that's pretty much all my ideas have come from somebody else.
I was kind of surprised the rest didn't pick up on it because T.C. and Bowl and Chamberlain were both at the University of Chicago.
Yeah, I think so. I think we were talking about this yesterday. I think so Brett knew about Glacial Lake, Missoula, but Brett was convinced that the floods came from the Spokane glaciation, which was the glaciation prior to the last glaciation. And so I think that situation at Moses Coulee where you have this flood bar with this glacial moraine on top of it. And if you're operating in a mindset that there was only one flood, which was Brett's mindset to begin with, that, well, if you have a glacial moraine on top of a flood bar, that the flood must have been from some prior glaciation. That's just speculation on my part, but I think that might have been part of his reasoning. But his reluctance to tie the floods to Glacial Lake Missoula was that Glacial Lake Missoula was the last glacial system, and the floods predated that.
You know, it's a little amazing to me that on all of the trips that Brett's made from Illinois, coming out here each year, that he didn't at least slow down as he came through Missoula. How much time did Brett spend in the Missoula Basin?
So he spent 10 years, about 330 days out in the field during that 10-year period, about 330 days.
How much of that would be in the Missoula Basin?
I'm sorry,
How much of that was in the Glacial Lake Missoula area?
Nah, he went only 1 year. He spent maybe a week or two over in Missoula. He's up in Canada looking for Curtis horses, and he did, in later years, did go to Missoula and spent a couple of weeks over in that area tracing the water. He's also up the Snake River too, looking, or the lower Snake River looking as well.
Yeah. So he knew about Glacial Lake Missoula. It's just he was reluctant to make that connection for whatever reason. I speculated about the timing being part of it, but I don't really know.
There's plenty of correspondence between Brett's and Pardee about, no surprise.
Yeah.
Brett's notes from the 1927 lecture, he talks about that Alden and Pardee may have some ideas about where the water came from, but he knew. It was a big surprise.
Well, he admitted it in his latest paper that he co-authored in the 50s, that the West Plains that he had under an ice sheet, he said, well, it may have been flood swept. So he was willing to admit that the floods had come through and there was no glacial ice blocking it. But, that was about the last time he wrote anything.
He was old tired and then.
Yeah, oh yeah. He got fed up with it all at the end of the 20s and said, I'm not coming back. I'm going to stay out in the Midwest and look at caves. So he said, I've said all I've got to say, go out and look at it. And if it doesn't convince you, then I won't be able to convince you. One of the USGS people, and you know this one well, Jim Cooley, who was very well respected, spoke out against Brett's at the meetings, came out on a field trip, and then admitted, I have never been so wrong in my life about anything than I was about the floods. And that's great praise with USGS, because they don't back down very easily.
Cooley may have been a high school student, Brett's.
Oh,
Yeah.
that's cool.
Yeah, Brett's taught high school in Seattle before all this happened back then. And Cooley was, from Seattle and went to, so Brett's taught at a few high schools, and Cooley went to one of those high schools. I don't know if the timing is the same, but I like to think that, there's some great stories like that. As Mike said, Brett's pretty much said, okay, I've solved this problem by 1930, and we moved on to different topics. But in the 30s, there was through a wave of resistance to the flood ideas, mainly made most famous by Richard Foster Flint. But there was others, Ira Ellison, and Hodge, and Hobbs, that came up with different explanations for the features in the channel skyline, and some of that were motivated Bretz's return to the field in 1952. But Richard Foster Flint was a PhD student at Chicago and went on some, and apparently Flint and Bretz had a history that dated back to that time.
Brett's failed him on his oral exam.
Yeah, that's the rumor that that Vic Baker has, stated a few times. I haven't found any actual written documentation of that, but Flint, from the notes and newspaper articles that have been dug up in conjunction with Zettner's flood series a couple winters ago, it's clear that Flint is named in one of the newspaper articles as one of the students accompanying Bretz in the gorge fieldwork.
But in '52, Brett's went back and checked out some of Flint's stuff and said he doesn't know what he's talking about.
Yeah, this is you hear lots of rumors about how and this also came from other folks too, Aaron Waters, who said, Flint has a great following, but he's not so great in the field in terms of. But so here I am just spreading rumors again. Yeah, this is the thing. These personalities play such an important role in how science progresses. And so in many ways, it's some jerk will motivate you to go back out there and figure stuff out even, more better. And I mean, this to me, it's fascinating. And I think if some of this was communicated to kids learning science, that there'd be more engagement